So I will try to solve the day 7th problem of this month in daily lead code. So yeah, it should be refreshed by now. Okay, it's a medium rated problem. Given two positive integers left and right, find the two integers num1 and num2 such that num1 and num2 is between left and right. Okay, both num1 and num2 are prime numbers. Okay, num2 minus num1 is the minimum amongst all other pairs satisfying the above condition. Okay, minimum. So they need to be as close as possible. Here in the positive integer array, answer equals to num1, num2. If there are multiple pairs satisfying this condition, return the one with the smallest num1 value. If no such numbers exist, return -1, -1. So they have given left equals to 10 and right equals to 19, and we'll have to find two prime numbers in between them with the lowest difference. So their output, they gave 11 and 13 as output. So I guess okay, the prime numbers between 10 and 19 are they calculated the prime numbers, and the closest gap that they found, uh, they 11 and 13, 17 and 19. So both of them are having a 2 difference. Like 13 minus 11 is 2 and 19 minus 17 is 2. So in between these two, they gave this one as output as num1 of this pair is smaller than the num1 of this pair. So that is what they said, that if you find two pairs that are satisfying, that are close, like the same close, same distance, then you will have to return the one with the smallest num1. So left and right, when it is 4 and 6, there are no prime numbers in between them. That's why they returned -1 and -1. So as we can see that we are given constant of 10 to the power 6, we can easily find the solution of O of n by O of n, not really O of n, but like O of n times the square root of n, which is still fine. Is it? Okay, so 10 to the power, is it still fine? 10 to the power 6 into square root of 10 to the power 6 is 10 to the power 3. So that's 10 to the power 9, and it exceeds 1 millisecond. So I don't really think it's a good solution. Maybe every time, maybe I can minimize the iteration by making some assumption, like the smallest prime numbers you can get is definitely 2, I guess. I don't think we can get any prime numbers that are more than that are less than the distance between the prime numbers can be less than 2, because it cannot be less than 1, because there will be a even number in between, for example 17, 18 and 19. So it's a prime number, and the second one cannot be a prime number as it is always even, and we know prime numbers are usually odd except for 2. So for 2 there is another prime number 2 3. Okay, for 2 3 maybe we can get the distance 1, and other than all other pairs I don't think we can get less than 2 any way. So yeah, that's one assumption we can make. And what else can we uh, do to optimize it? Can we uh, uh, if we can iterate till we get a pair that is that has a distance of 2, and we can see if that works. I think that will work, but can I prove it? Okay, let's try first, and then I'll try to prove it later. Uh, let's uh, let's start with writing a for loop for integer I equals to left, I is less than or equals to right, I plus plus. So okay, so I'll have to maybe keep vector of integer primes, and we'll have to find find the prime number here. So let's say integer x equals to I. I am storing the I in a temporary variable, and then uh, I will iterate over. I will write another for loop to iterate over it to find out uh, the find out if it is a prime number or not. For that, I'm iterating till square root of x, and I don't think I can do it from 1. I should be doing it from 2. And if any of the numbers, if j mod if x mod j equals to 0, if any of the number divides it with a remainder 0, then this is not a prime number anymore. So bool flag equals to, let's say, true initially, and if any of the number can divide it, then I will make it to false, like it's not a prime, so we can name it as prime. So it's prime equals to false. So if prime, like if it is a prime number, then I will push it in the array, push back prime, and before that I can take one answer equals to 0, and if I can check here, if uh, prime minus primes dot back, like I'm checking if the last one I found and this one has a difference that is less than or equals to 2. If I find one, then I will just terminate it here, return from here the primes dot back comma prime. So instead of keeping a vector, I think I can keep just a integer variable named last prime, last prime, last prime. Okay, last prime. So if I find a prime number, then I check if let's initialize it with -1. If last prime, okay, so if last prime is equals to -1, then I'll simply put the prime number that I just found in this variable. Uh, and if I found a prime number before that is stored in the last prime variable, then I'll just check if prime minus last prime is less than or equals to 2, then I'll return last prime and the number that I just found, and else if okay, else if what is happening, else if, and mm, if even if it doesn't satisfy, I'll just keep it in the okay, I can make this, I can write this like this, that last prime is not equals to -1, and prime minus last prime should be less than or equals to 2. If there's a case, then I will return this, and even if it's not, even if it is not the case, I'll restore in the last prime variable anyway. So how do I do that? Last prime equals to prime. So uh, it can happen. Can it happen that we don't find a variable that is find two primes that are not only distance, they don't have they have a distance more than 2. Can it happen? Like 7, what are the prime numbers? Okay, you're getting what's going on. Okay, this one got stuck for some reason. Let me open it. Okay, so now it works. Let me write the prime numbers. So 2, 3, 5, 7, 11, 13, and then 17, 19, 23, then 29. Okay, so I think I found a range at 23 and 29. So for that, I will keep I'll keep uh, answer equals to 0. So let's initialize it with int max, and let's say minimum that we found will be stored here, and we will check. Now we will check. uh, we will keep a vector of integers -1 -1. That's our answer equals to -1 and -1. And okay, so we store if last if prime minus last prime, like if the difference that I'm currently having is less than the distance that I previously found, the minimum distance that I previously found, I'll update the minimum variable with the new minimum distance that I just found, and I will store the current pairs in the answer variable. So last prime and prime. So I can write uh, else if else if. So if that's not the case, then I will have to also put it here. Yes, that should work. Okay, I will have to return the answer variable. Okay, now let's see. Time limit exceeded. Time limit exceeded. I equals to, for left equals to 10 and right equals to 19. So left equals to 10. So I'm starting with I equals to left, and I'm iterating till I is less than equals to right. So x will 10 will be stored in x. Then I loop over it. I plus plus, I'm doing I plus plus here, which is maybe causing the issue. Again, time limit exceeded. So j equals to 2, j less than or equals to square root of x. Uh, that's silly mistake. Output 1 and 1. 1 cannot be a prime number. So I can maybe write a base condition here, like if I equals to this 1, you just continue. Like skip it. Again one and one. And one, how is one coming? Like how are we getting a one? How are we getting one? Wow. So I'm starting from left and I'm storing that variable, let's say 10 in it, and then I'm keeping a boolean named prime and making it initializing it with with the value true. Then I'm iterating in a for loop. I'm starting from 2 till the square root of x, which is in the hypothetical case 10, and then I'm checking if 10 can be divided by j with a remainder of 0, then I'm marking it as not prime. And if it is not prime, I'm not doing anything. If it is prime, then I'm checking if last prime is not equals to -1, then I'm checking the difference. Else if last prime not equals to -1, and updating the minimum here and updating the last prime anyway, whatever the case is. So I am not supposed to get 1 1 as output, right? I have initialized them as -1 -1. So last prime comma prime, how is it 1 1? Uh, how is it 1 1? Let's let's try to do some debugging here by printing the I first. I'm getting 10 11 12, and then I'm terminating it. I'm terminating it when I is equals to 13, probably when I is equals to 13. So let's do do a print here. Yeah, 10 11 13. So I'm returning directly when it's 13, and for 13 I'm returning last prime comma prime. So last prime should not be let's print the last prime should not be 1. Last prime is -1 but I'm getting 1 here. Okay, I'm storing the variable prime, which is just so bad. Yeah, that looks okay till now. Uh, that was just a pure blunder. Like that is why we need to have proper names in our variables. They say, like I need to name it. Probably I needed to name it like prime flag or something, and I would have to use that variable as prime candidate probably. I don't know, but having proper name was really important. So I can get rid of this. I can get rid of this, and I can just do I here. Let's add some test cases. For example, 1 and 1. Another example, another test case should be 1 and 5, so that we get 2 3. Let's see. We need to get -1 and 2 3 for the test cases that I added. So -1 and 2 3. Let's submit it. Yeah, I got it. So yeah, I was just making a pure blunder here by thinking prime is my prime candidate, which was not. So that took a bit of my time extra, but it's fine. I think it's fine as I could solve it on the first run. So yeah, good day. Have a good day, everyone.